Today's lesson is on going the reverse direction. So you're going to be given an ellipse, and can you come up with the equation that goes with it? So remember that what the standard form of the ellipses look like. So our center is in the numerator. So HK, our center, squared, and then our denominator. Now for horizontal, the major, which will be A, will be in the denominator, and then the minor B will be there in that denominator. Let me find a pen that might work better. I had a nice pen. See if this one works better. All right, so a vertical ellipse, similar. It's just that the major and minor have been switched around. So that's what we're working with. So the distance from the center to the vertices is what A is. And then B is the distance for the minor, half the minor distance of the minor axes from the center to the minor, or the minor vertices. So to find C, remember that it is the square root of A squared minus B squared. And that's how we're going to find it when we find C, to find the foci. So let's go. I think it'll be okay today. So this is called an ellipse. The first thing I should do is identify where the center of this ellipse is. So you can count across and see how many, and then divide by 2 to try to figure out, okay, where is it? So it's at -1. And if you count up and down and find the middle, it's at -1 and 2. Right there is the middle. So you don't have to eyeball it. You can actually count across, divide by 2. Count across, divide by 2. So if the center is at -1 and 2, we have x plus 1 squared. That's in the numerator. We have y subtract 2 squared. That's in the numerator. And it's equal to 1. So just from the center already, we have that much. Now, if I count the distance for the major, in the major, because it's wider than it is taller, count from the middle and count to the right. How many do you count? And you count 7 to the right. So if I square that, that's now 49. If I count from the middle and go up how many that is, that's 3. And if I square that, that's 9. And we already have an equation that then matches this ellipse. Our vertices, so our major vertices, the ends here, they're right on the graph. So one is at -8 and 2. Again, this isn't 10 by 10, so it's 8 by 8. So -8 and 2, and the other one would be to the right, would be at 6 and 2. The minor vertices, top and bottom, would be at -1 and 5, and the other one would be at -1 and -1. So that's these here at the ends here. So we're finding those points, we're finding these points, our major vertices and our minor vertices, and put them down. Now for the foci, it won't be off the graph, it'll be off our equation. Because it's horizontal, it's the x coordinate. So that's -1 plus or minus, and we're going to subtract. So 49 take away 9, that is the square root of 40, and then 2. I'm not worried about you simplifying these. Number 2. Write the equation. What do I notice about it? So first of all, it's vertical. So when I find the major distance, the major axis, make sure it goes under the y. First, I need to find the center. So count up all the way down and then find the middle of what that is. So for this one, the middle is going to be at -2. Horizontally, it's easier to find the middle, but right there is the center. So that center is at 3 and -2. So we're going to write down x subtract 3 squared. We're going to write down y plus 2 squared. And that's equal to 1. I am then going to find the distance from the middle to the top, and that's going to go underneath the y. So if I find that, that's the distance of 5, and then square it, that's 25. And then from the middle to the right, that's 2. So if I square it, it's 4. So my vertices are here. These are my major vertices, top and bottom. So write those down. That's at 3, 3. And the other one is at 3, negative 7. The minor vertices are right here, left and right. So for the minor vertices, that's at 1 and negative 2, and at 5 and negative 2. So those are the minor ones. The foci, this one's going to do with the k, or the y-coordinate of the center. So the center's at 3 and negative 2. It's to the negative 2 I add and subtract. And then what number am I doing? So 25 take away 4. So it's the square root of 21. Done. Number 3. Ooh, that's a skinny looking ellipse. But notice it's horizontal, so that's important to me. So where's the center? That should be easy to find right there. The center's at 0 and 5. So that means we have x squared, and we also have y subtract 5 squared, and that's equal to 1. Now, for the major axes, the distance from the center to one of the major vertices, count across, and that number is 8. It's an 8 by 8. 8. So 8 squared, that's 64. For the minor, it's only 1. So we don't even need to put it there, but we will. It's 1 squared, or 1. Now, the vertices here, we have the minor and the major. So here are the major, and here are the minor. So for the major vertices, that's going to be 8 and negative 8. So negative 8 and 5, and positive 8 and 5. For the co-vertices, that's going to be 0 and 4, and 0 and 6. To find the foci, is it going to affect the h or the k when it's horizontal? So it's the h. Now I don't need the 0 there, so it's just plus or minus, and you subtract the denominators, which is the square root of 63, and then the y-coordinate for the center, which is 5. All right, turn the page. Next, you're not given a graph for this, but you're still going to write down the equation by what's given. So for this, find the center. It might be finding the midpoint formula to find the center. Use the vertices to find A and the minor vertices to find B. And then if given the foci, you'll have to use this formula to be able to find any missing part. Determine the direction of the ellipse to write the equation. All right, so first of all here, the vertices are 5, negative 2, and negative 19, and negative 2. So when they say vertices, that's major axes. And I want you to notice for the major axes, it's the x, where the x value has changed and the y values stay the same. Because of that, this is a horizontal ellipse. So the x values change, but the y's stay the same, so the y's are the minor. All right, to find the center, we're going to find the midpoint. That means we're going to add them and divide by 2. So that's 5 and negative 19. That's negative 2 and negative 2. And then divide by 2. As we move on, I'm not going to write it all out. So that's negative 14 divided by 2. That's negative 4 divided by 2. So there's your center at negative 7, negative 2. We also need to know what A equals. Now, to find what A equals, take the x coordinates and find the difference between them. So that would be negative 19 and 5. So find the distance between negative 19 and negative 5. So that distance from negative 19 to positive 5, how wide is that? And we want to find it from the center, sorry. So the distance from the center, So take either one, and from the x value of the center, we're going to use it. So take negative 7 and subtract 5. That's fine. And it's the absolute value of what we're finding. So it'll always be that positive value. So what is the distance from the center? And you could have picked either x coordinate for the major. And that answer is 12. So already we know this. We know that the center is going to be x plus 7 and y plus 2. It's equal to 1. We know that the a is 12, so 12 squared is 144. We're not given the co-vertices here, so how are we going to find the other length in terms of what we're looking for? Oh, and it tells me the length of the minor axes is 10. So then if the whole length is 10, I just divide by 2. And that means for the minor axes, I'm going to use 5. And then what do I do back in the equation is I square it, and I get 25. So can you take information, work backwards to get your equation? Let's try again. Now, co-vertices means minor. So which one is the minor? So 9, 1, negative 3, 1. Notice the y-coordinate stayed the same. So the minor then is going to be horizontal, which means this is a vertical ellipse. So let's first of all work with that. So even with the minor or major vertices, the midpoint would still be the center. So to find the center, we're going to add them. 9 and negative 3, that's 6, divided by 2, that's 3. 1 and 1 is 2, divided by 2. So the center is at 3, 1. Next, the length, the co-vertices here, I need to take the x-coordinate and find the distance. So what does b equal, because it's minor? 3 to 9, that distance is 6. The major axis is 28. So that means if I divide it by 2, that's what gives me 14. And now I can write my equation. So it's x subtract 3 squared. It is y subtract 1 squared. That's equal to 1. Make sure the major goes underneath the y. So 14 squared is 196. 6 squared is 36. And you have your equation. Number 6. Let's see what's given. So the major vertices are given. Now notice which one stays the same and which one changes. So because the x changes, it's horizontal. So first of all, I want to find the center. So add them. 12 and negative 6 is 6, divided by 2. Negative 9 and negative 9 is negative 18. And if you go negative 18 and divide it by 2, it is negative 9. Next, we're given the major vertices, and take and understand, again, the A is going to go with the horizontal. So what's the distance from the center to there? So the distance from the center to the x-coordinate is 9. Now notice the co-vertices, the minor, take the y-coordinate with the center. So what's the distance from negative 9 to negative 7 or negative 9 to negative 11? The distance there is 2. And now we have everything I need. So it's x subtract 3 squared. It's y plus 9 squared. That's equal to 1. Now be careful. Our major is with the x. So the 9 here, we're going to square it. The minor 2, we're going to square it. And we have our equation for our ellipse. Number 7. Here we have vertices 0, 12, and 0, negative 18. So those again are major. Notice the x stayed the same, but the y changed. So this is going to be a vertical ellipse. I still need to find the midpoint. So if I add 0 and 0 and divide by 2, I get 0. If I add these together, 12 and negative 18, that's negative 6. Divide by 2, that's negative 3. So there's our center. To find our A, it's the y value with the y value. So negative 3 to 12, that distance is 15. And then for the B, I need the minor. So the minor vertex is at 4. So take 4 and 0. What's the distance? That's 4. Now we have what we need. So the center is at 0. So I just have x squared. For the y, I need to put down y plus 3 and square it. And then the denominator. Well, this is major. This is, again, a vertical. So this is going to go with a y. So square 15, 225. Square 4, that's 16. And you have your equation for your ellipse. Number 8. Vertices and foci. So let's try that. So first of all, define the center with the vertices. Add and divide by 2. So 5 and 5 is 10 divided by 2 is 5. 11 and negative 15, that's negative 4. And divide by 2 and you get negative 2. Now notice your major vertices, the x didn't change but the y did. So this is vertical. So if I want to find what a equals, take the distance from the y coordinate to the y coordinate. So negative 2 to 11 or negative 2 to negative 15. So either way, the distance, and it's going to be written as a positive number, is 13. The b, I don't know, but I'm going to use the foci to find the b. Now the definition of foci is c equals the square root of a squared minus b squared. So in this situation, if I look at it carefully, c is the distance from the center to the y coordinate. So because it's vertical, what's the distance from negative 2 to 10? So that distance is 12. A squared is 169, and I need to solve for b squared. So I need that equation and then solve it. So to get the square root by itself, to undo the square root, I square both sides. And then I subtract 169. So 149, take away 169. That's negative 25. Divide by negative 1, square root. So if b squared equals positive 25, that means b must equal 5. So now I have what I need. I have what b equals, I have what a equals, and I have the center. So let's put it together and do it. I'm going to do it here on the left. So the center would be at x subtract 5 squared and y plus 2 squared, and that's equal to 1. Because the major is y, a, 13 squared, goes underneath the y. We found b to be 5, so 5 squared, 25, goes underneath the minor, and we have our equation. All right, one more time. This is our last. No, we got one more page after this. 9. Teasing you. So the vertices, the major, define the center. 15 plus negative 7 is 8. And then divide by 2. And it's 4. 3 and 3 is obviously going to be the average. Atom divided by 2 is 3. Our a is the distance. Now be careful here. Which one changed? The x's. So the x to the x. The distance is 11. So a is equal to 11. If I was looking at the c, what's the distance from the center? So notice this plus or minus root 21. So that root 21 is telling me what c equals, because that's what I'm adding or subtracting to 4 to find the foci. So I already have a lot of information. So I'm going to actually write down c squared is equal to a squared minus b squared. Because in this case, it's easier to write it that way. So what's c squared? 21. A squared is 121. Subtract or add. I'm going to actually add b squared and subtract 21. And then take the square root. So b, is equal to, knock off a 0. B is equal to 10. So if I put this together, now I have room. The center is at x subtract 4 and y subtract 3 squared equal to 1. A and B. Is this a vertical or horizontal ellipse again? So I look, the x has changed for the major. So the A goes with the x. So that's 11 squared, which is 121. And then the y is the minor. So b squared, here, that's 100. So I actually didn't need to go this far. I could stay at b squared and just plug in what b squared equals and not go all the way and solve for b. All right, now we're getting to the end here. The questions to do with eccentricity, we're going to skip. So that's the last two. So we have 4 more. The co-vertices are 0, 6, and negative 6, 6. So I need you to know, can you find the center? At this point, we should be at the point where maybe we're pressing pause. We're trying our best to do it, and then press play to see if you did it correctly. So we're going to add them and divide by 2. And the y's, well, the average is going to be 6. Did the x or the y change? So notice the x coordinates changed there. So because the x coordinates changed, A is going with the x. So go from x to x, and the distance is 3. Oh, no, those are the co-vertices, and the x changes. So that's actually the minor. So the B is equal to 3, because they're co-vertices or minor vertices. To find the A, we need the foci, and we need to know what C equals. Notice it's plus or minus 2 root 10. So it's right there. That's what C equals. And then we're going to go C squared is equal to A squared minus B squared, and use that to find B squared. Once I get to B squared, I'm done. So C squared, that's 4 times 10, which is 40. A squared, I'm looking for. And it's the B squared, that's 9. So I'm going to add 9, that's 49. Take the square root, and that's 7. Oh, remember, I was not going to do that, right? We're just going to stay here, that A squared equals 49. Now I can write my equation down. So my equation then is x plus 3, y minus 6 equal to 1. Note my co-vertices, B is horizontal. So the 9 actually goes here underneath the x. And A squared, A is actually underneath the y. And you have your equation. All right, let's try again. Number 11. So again, press pause, and then press play when you've done your work. So again, the co-vertices. So first of all, I'm going to average. So this is negative 9, and that's negative 14, so that's negative 7. There's step 1. My B, in this case, because it's co-vertices, is negative 7 to negative 3. That's a distance of 4. Then, to find my A, I'm going to go C squared is equal to A squared minus B squared. So I'm looking for A squared. So in this case, C squared is going to be, and C is equal to 4 root 3. I'm going to square 4 root 3. So that's 16 times 3, which is 48. B squared is 16. I'm going to add 16 to the other side. So that's now 64, and that's what I need. I need to know what A squared equals. So now my equation. So from the center, x plus 9 squared, y plus 7 squared equal to 1. Now the denominators. So what type is it? The co-vertices. Notice the y changed for the co, so the B actually goes with the y. So 4 squared is 16. And then the 64, which I just found, goes with the x underneath. All right, 2 more. The length of the minor axes is 8. So if it's minor, it's B. I divide it by 2 and know that B is equal to 4. The foci is going to give me the center. Again, the foci is equal distance to the center, meaning the midpoint of the foci is also my center, just like with the vertices. So I'm going to add and divide by 2. So 16 divided by 2, and then 0. I already know B is 4. I know that the center is at 8, 0. So what does C equal? Even though C is the center, what would C equal? What's the distance from the center to the foci? And that answer is 3. So I'm going to use that the C for the foci, and this big C is the center, to find what A squared equals. So I know that C squared is equal to A squared minus B squared. That means it's 9. That means I don't know A squared. And that B is 4, so when you square it, it's 16. We're going to add 16. And now I know what A squared equals. I don't need to go any further. I now know my equation. And the equation is, from the center, x subtract 8 squared. And y doesn't need anything, so you don't need to go y minus 0 squared, and that's equal to 1. Be careful what your minor and major is. Look at the foci. That's along the major. Notice the x's changed, but not the y's, so the x's get the major in this case. So A squared 25 goes underneath the x's. B was 4, so 4 squared is 16. That goes underneath the y. And there's one more to do. So again, press pause and do your best. So the length of the major axes. So if I take 18 and divide by 2, I know that A is equal to 9. The foci, I need to understand in terms of where the middle of my foci would be. So what's the midpoint of my foci? Well, if I look carefully at the pattern of this, what you're adding or subtracting, root 77, that's what your little c equals, meaning 1 and negative 9 is where the center of your ellipse is, and you're adding that to the center to find the foci. So 1, negative 9 is embedded in your answer there. So the only thing we don't know that we need to find is b squared. So we know that c squared is equal to a squared subtract b squared. If I square this, that's 77. A, if I square it, it's 81. And I'm looking for b squared. So I'm going to add b squared. I'm going to subtract 77. So I know that b squared is equal to 4. Now put it all together. So that's x subtract 1. That is y plus 9. And that's equal to 1. Now, the a squared, which one is major? So if I look, it's the y value that's being added and subtracted for the foci. So my a squared, where is it? 81, goes underneath the y, and my b squared, 4, goes underneath the x. And you did it. You were able to write the equation either based on a graph or information you're given and work backwards from the other day in the lesson. This is Mr. G Math. I'm proud of you. Thank you for doing your work, and until next time.